Hey guys, this is Fred from Pretty Fly Games, and this is episode 4 in how to build an agar.io clone using Photon Fusion and Unity. In this episode we'll go through how to add bots to your game. So now we're going to add bots to our game, and we're going to make it as easy as possible. So we are going to reuse our network player for this. So let's open our network player in Visual Studio. So the first thing we need to determine is if this player is going to be a bot or not. So let's add a public bool is bot, which is false as a start. And we will also add a not only join game, but let's add a bot join game so that we can write it to the server log that this has happened, that a bot has joined, and then we'll do a reset player. And then we need to change our network spawner so it can spawn bots as well. But before we do that, we need to decide how many players are we going to have in our game. So we first of all, let's say that we have this is food spawn. So let's do bot spawning in the same way that we do food spawning. So let's just add that is bot spawn false. And then we need to decide, okay, how many players are we going to have in our game? So in this example, we're going to use 30 players. So if it's less than 30 players, the server is going to fill up the number of players with bots. So we have a total number of players that's going to be 30. So even if one player joins, then we want to fill up with 29 bots. Then we also need to keep track of our bots once they have been spawned, and we're going to use a list for this. So let's add a list of network players. We'll call it bot list, and just a new list. Then let's add a new function, call it spawn bots, and there we go. So the first thing we need to decide or check is there a need to spawn any bots, because this will be called periodically. So first thing we do is we're gonna take our runner, get our session info, and check our player count. So that determines how many players do we have, and if it's less than the desired number of players plus how many bots we have, then it means that we are lacking players. So once we have checked this and determined that, okay, we need to spawn some bots, we need to figure out how many bots do we need to spawn. So we create a variable number of bots to spawn, and it will be the desired number of players minus how many players we actually have minus how many bots we have in the game already. Okay, so let's just write that to our debug log. So number of bots to spawn is the value number of bots, and then we'll add our bot list count and how many players we have. Perfect. Then we need to actually spawn the bots. So let's do a for loop where we loop between 0 and the number of bots to spawn, or less than number of bots to spawn. And let's spawn an AI player. So how we do that is exactly the same way that we do when we are spawning a player. So we're going to do runner.spawn with the player prefab. We're going to get a random spawn location, and then one difference is that we are going to add this part, which is the on before spawn. So this code here, this function, will be called before the spawn code is completed. And the reason why we're doing this is because in this we want to set that it's a bot, so that the rest of the code will know that, okay, this is a bot, and we're going to treat it a little bit differently. So let's add that so that that error disappears. So we're going to do a private initialize bot before spam, network runner, and the network object. So we'll take our network object, we'll get the component, the network player, and say that isBot is true. So that will be called here before we have spawned the player. Once the bot is spawned, we want to assign a random color, just as we do with the player. So let's do a spawned AI player sprite color and get our random color there. Okay, so now we have spawned an AI player, a bot, and it has a random color. So then let's call this bot join game, so it is added to our debug log as well. And then we will add our bot to our list. So let's add that to our bot list. Great. And then we are done with this, so we can say that, okay, is bot spawned. So then let's spawn this in the same place as we spawn our food. So let's check, is food spawned here? So let's do the same, is bots spawned? If they're not, let's spawn the bots. Then let's go back into our network player and just add one little thing. And that's when we have joined our game, then we are going to get our spawned, or when the bot has been spawned, then we are going to get our spawned event. And when that happens, we want the bot to receive a random name. So we will do a check. If it's a bot, then let's assign a nickname and we'll get a random name from our utils. So that gets us a random name. Then we need to add some movement to our AI so it doesn't act like a player. And that's in our movement handler. And we need to determine if we are a bot or not. So let's grab our component. We're going to grab our network player, here. And in the awake function, let's just get component to get it. Okay, so then we have our network player. And then in our fixed update, then this is where we are going to make some changes for the AI to actually be able to control our bot, basically. So what we want as well is we want the AI to follow some type of target or move in a certain direction. So we're going to have it follow a target. So let's add a variable which is going to be called the AI target, which is going to be null as a start. So when we are coming into our fixed network update function here, and we have determined that we are the state authority, then we want to add some special code if we are a bot. So before all of this movement, direction, etc., let's just add a check and say that are we a bot or not. So if we are a bot, then we want to make sure that we have a target. So if we don't have a target, then it means that we need to acquire one. So we're checking, is the target null? And if it is, then we want to get a random target. And our AI is going to be super basic, so it's going to search for food. So we'll find objects with the tag food and we'll assign it to our food targets, which is an array of game objects. And then we will pick a random object from this. So we will see that, okay, random between 0 and the maximum length, and we assign that as the target. If we do have a target, then we can actually do something about that, and we want to move in the direction of the target. So we need to determine the direction or the vector to the target. So we'll take our transform's position minus the target's position, and then we will normalize it. So it will be a direction between -1 and 1 in the x and y coordinates. And we will override our input and say that, okay, our input direction is going to be the direction to the target -1. So we will have the inverse of that. So it will move the bot towards our target. So remember that only the server, which has state authority, can move the bots. So no other players are able to move the bots. And our get input here will actually fail on the server for this object but it doesn't matter because we're overriding it with the instruction for the AI here. So let's save this and take it for a spin. So let's hit play and see what happens. Alright, so let's give ourselves a name, Fred, and we can see that we already have some bots moving around and playing the game. So let's join in as Fred, and we can see that, yeah, we have some bots, and if we look at our scene, we can see that, yeah, they are all moving around and playing the game, which is great. But there are some cases which are missing handling, and that is if we have a look at our scene. After a while we will see that some of the bots are sort of not moving around, and the reason for this is because once they actually die, they will get despawned by the server, not shown by the server, and they will not respawn again. So that means that eventually this game will run out of bots. So if we look at our list here, we can see that we have a bunch of players, and some of their sprites are going to be disabled. They're going to be like this. So we can see that this player here actually has disappeared, and that is when what is happening when our players are dying. Their states are changing, which causes their renderers to disappear, and also their movement handler will stop working. So that is something that we need to adapt in our code for bots to be able to get them to respawn again. So let's stop our game. So let's open our network spawner in Visual Studio, and we want to check periodically if we're going to spawn or enable new bots. So let's add a tick timer to this so that we can check if we need to spawn our bots or respawn our bots. We'll add a bot respawn timer, which is a tick timer, and this tick timer is going to be executed in our fixed network update. So we have simulation behavior, which means that we can also use our fixed network update. So let's add that here, and in this we are going to check if our bot timer has expired, and if it has expired, it means that we need to do something. But right now it will not expire because it has not been triggered, but that is something that we will deal with a little bit later. So first of all, we are going to check how many bots do we have that are alive. So how many bots do we have that is still alive? So to do that, we need to figure out actually if we have any bots that are alive. So we'll do a for each loop, and we'll go through all the bot network players in our bot list, and they are just plain network players. And if they are in the state that they are playing, then it means that they are alive. And if we find a bot that is not alive, then that is a bot that we're interested in, because we want to be able to revive it. So let's actually store any dead bot, and we'll put it in here. So if we find a dead bot, then we are just going to do an else statement and say that, okay, we are going to store this dead bot. Okay, perfect. Then we are once again going to check how many bots do we actually need. So we'll do it in the same way that we did before. We're going to take the number of bots to spawn, which is the desired number minus the player count minus alive bots. So then we know that, okay, this is the amount of number of bots we want to spawn. So let's add that to our debug log. And if it is bigger than 0, so we want to spawn a bot and we do not have any, or we have a dead bot that we can reuse, then let's call this dead bot's bot join game, which will cause it to actually activate again and resume the game. So we can have a look at our bot join game, which is going to call our reset player, and our reset player is going to get a new spawn position. We're going to teleport it there, and then we're going to change the player state to playing. So that's awesome. And then we want to check again here, because we have just spawned one bot, and we don't want to spawn all the bots at the same time because it's going to be look quite strange, and we wanted to sort of mimic a player's behavior where new players are joining in. So we are going to make a check and say that, okay, if we have more bots to spawn, so if number of bots to spawn is larger than 1, then we are going to say that, okay, we're going to rerun our tick timer, and we are going to run it again after 2 seconds. So we're going to do a create from seconds runner 2. If we don't have any more bots to spawn, then it means that we are done, and we're going to set the bot timer or bot respawn timer to tick timer none. If we don't do this, it will run this code in the next frame, and it will come to this, and it will still be expired. So we need to make sure that it's not expired anymore. And then I need to fix my code a little bit because I missed to add the brackets there. Okay, great. So then the problem is that this code will never run because nothing is starting the timer in the first instance. So we need to start our timer here. And how we want it to work is when a bot is dying or is dead, then we want this timer to start. So we need to understand when a bot has actually died. So after our spawn bots and initialize before spawn, then we're going to add a new function. And we are going to call it onBotDied, where we pass in our network player. So that's a signal to us that, okay, a bot has died, we need to do something. And again, we are going to check, do we need to spawn any bots? So if the player count is smaller than the desired number of players, then it means that, yeah, we need to actually do something with our bots. And let's just add it to our debug log, bot died, or actually we can have that, we can add bot died, respawn. Okay. And then we want to start our tick timer. But before we do that, we want to check if it's already running, because it could be that we have started to spawn another bot and it's still running and it's not ready yet. And in that case, we are going to say that, okay, if it's running, don't do anything. If it's not running, we're going to start again after 2 seconds. Okay, perfect. The only problem now is that something needs to call this function. And the natural place for this is to add it in our network player. And the network player, let's add so that we can access the network spawner. So let's add that component. And let's get our network spawner. And we will do it in the same way as we do it with our UI handler. So let's just find that object, find any objects by the type network spawner. And actually, we can use the same code, so we don't have to use any object. Find object of type network spawner. Okay, so then we have access to our network spawner, and then we want to determine when are we going to call this. And we already have our on player died here, but we can also do it here. So we want to check here if we are going to call this. So if we look at our bot where it's logical, so let's add it here. So if we're a bot, then we're going to tell our network spawner that our bot died. So on bot died, and we'll send in this, which is going to be the network player. Okay, so let's save that and try it in Unity. So I already compiled a client and a server. So let's get the server started, make it a little bit smaller, and then bring in a client. And here we go. Let's see. So now we're waiting for it to connect, and once it's connected, and we can see that, well, something is not really working as it should, but we do have some bots, and they appear to die and respawn. The problem is that when they are starting, something is off. We can see that it flashed there for a while, and some bots are flashing all over the place. So we need to figure out what's wrong with our code. So let's stop our clients. There was some bugs in this that I actually didn't expect, so I had to do some research and figure out what was wrong with my code. Let's open our movement handler. And the first part where everything is sort of starting at the wrong position is something that I didn't notice until I added the bots. So our issue seems to be caused that we are doing a couple of things with the movement handler. One part is that we are actually never calling this reset, so which means that over time the bots and the players will increase in size. So we need to make sure that we are calling the reset function. So if we go into our network player here and have a look at our code when we have on player died, which we are changing our networks to dead, and that's sort of not the problem here. We can do a reset here, but we can also do it when we are actually doing our reset code. So let's figure out where that part is. So reset player, and after we have done our sort of teleportation here, then we need to get our movement handler and do reset. Okay, so that will cause the bot's size to become 1 again once they have died and they need to restart, and the same for the player. The spawning problem where all the bots are spawning at the center is caused by something else, and it's actually a combination of things, but if we have a look at our on player state change here, what we are doing here is that we have done a reset and we have teleported the player to another place, but we have our movement handler disabled, and this seems to cause some problems because it is disabled when we are changing the position, and once we are enabling it again, it will eventually synchronize to position 0, and I'm not really sure why that happens, but it seems to be because we're disabling and enabling this. So let's get rid of that, and we will keep the movement handler active at all times. And what we will do instead in our movement handler is that we will say that if we are running our fixed update here, so we will check if we are not in a playing state, and if we are not in a playing state, then it means that we shouldn't move the player, so we will do a return in that case. But we will also add one more thing, and that is just for debugging and make it easier to see what is going on if we want to check what has happened after a player has died. So we will force the object to stop when it's dead, because even though we're not running our fixed update, as we have applied force to a rigid body, it means that it will keep moving even when an object is dead. So when an object is dead, we're going to force the velocity to be 0. That will force it to stop. So the last bug we had is a glitch, which is caused when the bot is being respawned, where you can briefly see it flash for a little while and then it disappears. And this is a little bit tricky to figure out what exactly was causing it. So I'm going to show you how I figured that out with some debugging. So we'll add a list of vector 3s, which is going to be called debug positions. So that's going to be where our players are dying. And we are going to only debug this on the client side, because this is actually only a client problem. So we're going to check if we are dead and if we're a client. So we're going to do runner is client and the player state is dead. Then we're going to add our debug position to this list, or the transforms position to the debug death position list. And then we're going to draw it, and we're going to use gizmos for this. So gizmos are drawn only in the editor, so we're going to debug that from there. And we're going to loop through our death positions, and we are going to change our gizmo color to blue, and then we are going to draw sphere at the position of the death with 0.2 delay, or a size of 0.2, sorry. And so let's save that and try it in Unity. So I already pre-compiled a server, so let's get that going, and then let's start our client. And we actually, well, the first thing we can verify is that, yeah, the problem with the spawning, that they are spawning at the position 000 is gone, so that's working. And if we look at our scene view, we can see these blue dots when something is dying, basically. So if we have a look at, let's find a new one. See, here was a spawn recently, actually. Let's try to figure out. There was a glitch, and there was another glitch. So the glitches are appearing on the places where something has died, and when it's actually getting respawned a little bit later. And it takes some time before the clients are, or the bots are being reused. So it takes a little bit of time to find them. But if we have a look at the screen, we can see that, yeah, they are appearing at these blue dots after some time. So the problem is a visual problem, and it's because when we are actually teleporting the bot, or the player for that instance, to another spot, it actually takes a little bit of time before that position is updated. But we're showing the graphics before that update has happened. So that is why we have this short little glitch. So let's stop that, and let's go into our network player to figure out what we can do to fix this. So the problem we have here is that we are, if we look at our states, we are changing our state, and we are showing the sprite by enabling or disabling the sprite renderer, which is fine, except for the case when we have not teleported to a new position and we are showing this. So how can we solve this? Well, we're going to do it the proper network way of actually using a tick timer for this. So let's add some code for that, and let's go into before our debugging. So we're going to add a variable, a boolean, enabled sprite renderer, which is going to be true as default, and then we're going to have a tick timer, delayed enabled sprite renderer, and new tick timer. And if we look at our code, then we need to go down into our section where we have our sprite renderer. So this part of our code, we're going to actually move it, This whole section, let's get rid of that, and let's have enabled sprite renderer to true, because if a player is playing, then we want to show it. So then we are going to launch our tick timer, and we're going to check is it already running, or if it's not running, then we are going to start it. There we go, delay sprite renderer, and we're going to go tick timer, create from seconds, and then we're going to go runner with 0.1. Oh, not. There we go. And then we are going to do the same thing here. So let's get rid of this. And in this case, it's going to be false. And then we need to build our tick timer. So it needs to be running in the fixed network update. So let's add our code here. And we are going to check then if it is expired. And if it's expired, then we are going to either disable or enable our sprite renderer. So set active with enable sprite renderer. And then we also need the camera control to actually move to our player. So let's check if we have input 30 and we are enabled. Then we are going to move it to this position. And then we need to just stop the tick timer from running again. So let's save that and try it in Unity. So let's start up our server, and I will just move it out of the way. And then we will press play. And hold on, we can actually look at our scene view. Here we go. And so let's see what's going on, and if something is going to kill something else. Alright, so now we have a few cases where this has happened, and if we look at this sort of death zone, we can see that actually there are no glitches going on. So this code change worked. So if we look at our game, we can enter our game from the editor, and we ate another player, and now there are sort of no glitches, and we have quite smooth gameplay, and the bots are running around and getting respawned and without any sort of problems. So yeah, that solved our bugs that we actually had. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode, and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out.